Well, g'day, Max there again, welcome back to the shop. So, been a while since we've worked on our lathe, well it seems like a month of Sundays, so we'll start back on that. We had a few, not delays or anything like that, we just had some other bits and pieces we had to attend to. So we got a little bit of work done up at the block, and we also knocked out a couple of videos for Emma Ritson and John Creasy for the Tiplets 19 that they organised, so that's done now. And because of that, so many videos, YouTube machining videos on tips and that to watch, you know, take you a month of Sundays to watch them all though. I've got through most of them, so that's good. And then on top of that, there seemed to be an unusual amount of extra people's normal videos which they put out. Just seemed to all come at once, so and I had to get the fluff trimmed up on my beard, so that's all sorted. So we'll hook back into our lathe, shall we? Okay, I want to modify a few things on this apron while I have it off. You can see here the oil level sight glass. Now I keep that right up full all the time. The oil it doesn't leak. If it did leak, it's not really a big issue. What I'm going to do is probably drill another hole, probably somewhere in a clear open area like here. I've just got to calculate the height to go so the apron will contain a higher level of oil. Now what my thoughts on it with that, if we come around to the rear of the apron, okay, we have this gear drive. So if I can keep the oil level somewhere around this level here, the oil, some of it will migrate through this bearing and it will leak through onto this gear and down onto the worm, and it will fill up this cavity here and lubricate the worm on the ends as well. So then I might make because nothing happens in this area, so there's no reason why I can't get a piece of sheet metal and attach it as a bit of a cover, a shield, to stop the chips constantly going in here. Now if we look inside the box, I don't know if we're going to be able to see this shaft here. So if I keep the oil level up to that shaft, I'm always going to have a constant leakage of oil lubricating our input drive. So that should solve the problem of this running dry all the time. And if I've got the shield over it, it'll keep all the rubbish out. The other thing I was looking at doing is some way of modifying the half nut assembly here. Now I want to be able to get oil to the slide. I want oil to be able to come down to here. So whether I have to grind a bit of a leading edge in on this edge here and then mark the position on the carriage on top and drill and tap a hole, or drill a hole, put a plug in it directly over that position, so I can dribble some oil down and it will run down and lubricate here, and it will run down the dovetail slides. The other modification I want to do to it, this threading dial here, I want to mount that on this end here. The reason for that, going handheld so a bit shaky, is it constantly fills up with swarf and rubbish inside. There's just no way of keeping it out. So if it's mounted on the opposite end where you don't have that, it's out of the line of fire from the swarf, that will improve things there. So I might even have enough room to maybe put a bit of an extra shielding around here as well to help help the situation with the rubbish that gets in these half nuts. And there's stuff that just gets in everywhere, so that's the plan. So we'll get a strip down and oil drained out of it, and we'll start on this. Okay, so we're going to make our protective cover now for the input drive for the apron. So it'll just be it'll just come down and curve around and cover the sides as well. So what better material than the old trusty can of spaghetti. So we'll make use of that tin and do a bit of sheet metal work. Okay, so we'll cut the ends off, cut it down the middle and unroll it. Okay, well, here's our protective cover now we have over the feed drive mechanism. Just a recycled spaghetti can soldered together. So that'll keep all of the chips and rubbish out of that drive worm. So next we'll move on to the extra lubrication for the half nuts. So okay, our half nuts. It's the next operation, the next mission. So we'll get rid of our thread dial because that will be mounted up the other end. And that will keep it out of the line of fire from the chips and rubbish. So off with that. This thing has actually been counterbored in to take the head of the grub screw on both sides. So I have noticed this model lathe that's sold in America, it's like the whole apron seems to be a mirror image of the one that we have over here. So we'll put that aside for now and we'll drill and tap the rear and we'll mount it there in its appropriate location, which we can pick up off the top and measure down. And we'll have to take a measurement from the front into the hole because as this surface here we can't reference from here either because they don't line up. So okay, we'll get these undone. So all we have to do is has a dovetail, a bolt in a dovetail section. There is an adjustment on your half nuts on these lathes too. Now, just here, there's an Allen key, and you can unscrew him. It's a spring and a ball, or spring and a detent, and that, when you adjust that, that sets the tension on how hard it is to engage and disengage your lever. So that's the idea of that. I prefer quite a light engagement on it just to get a bit of a feel when you're feeling into the lead screw. Of course, when you are using your thread dial, you should be starting to engage just before your number comes up on the dial, and you'll feel the crest of the thread on your half nut just touching on the crest of the thread on your lead screw. So that's why I like a light engagement. I can feel that, and then it will just automatically drop in then. If you clamp down without feeling it, the crest of the thread in, these can clamp on top of the crest and you'll start screw cutting out of pitch. You'll just, the first thread, you'll realise what's happened and things will just turn ugly. So There is a detent in there, we'll get him out in a sec. Okay, we're back. The camera got full of photos, video, so it stopped recording. Lucky I picked up on that. It made a little beep. Otherwise I would have been pulling this apart and waffling to myself. Okay, here's our dovetail, and that's full of crap and grit. Now the top section of our half nut. So that slot there, that's the engagement slot. Slots into this, there's a pin here. You can just see it. So you'll see that pin, as that pin moves, that's what brings your half nuts together. Now I better not mix these up, they're full of rubbish. Oh, okay, the lower one is a different size slot. I better mark that, I think. So get the letter stamps, I'll just mark a letter L on it. L for lower, we don't get them mixed up. The upper one's quite clean, but that lower one's full of rubbish, so good thing we did pull it apart. Now, I'll stop and scratch my head and come up with a design idea so we can get a bit more oil into these. Actually, because we're raising the oil level, we might be alright. We might get a bit of leakage through this engagement part here. Let's bring you around. We might get a bit of seepage out of here, which may travel across, so let me have a look. We'll come up with a plan and bring you back. Well, okay, what I think I'm going to do, I'm going to drill a hole through the casing there and then drill two little tiny holes on either end of the top half nut. Now the two little tiny holes will be for a retainer to hold a little tiny split pin. So I went and seen my lovely wife and got her piece of her wick material out of her oil candles. So what we're going to do is we're going to run a wick down in the oil reservoir in the apron. The wick will come up, come through a hole that we're going to drill in the top here, and then the split pins will hold the wick in location in the top. Then we'll file or grind the top half nut, just say on a 30-degree angle, so the oil that gets sucked up by the wick will just pull in there and it will make its way through to the dovetail slides, hopefully. So very carefully drill a 1.5mm hole in two positions. Okay. Deburr. Well, okay, this is what we've come up with. So we've got a wick which dangles down into the oil reservoir inside the apron. So the top of the half nut, we've ground it back on a 30-degree angle, back towards the slides. Then those two holes that we drilled, the 1.5mm holes that were drilled into the top of the half nut, what we have is two split pins going in there, and they retain the wick. So in operation. So capillary attraction is what it's known as, when the wick sucks the oil up and travels along and deposits it where it's got to be deposited. So hopefully it'll work. Okay, so we've pulled all our drive worm and gear out, and what I've done now is I've filled it to the oil level that we're going to run in this thing, which is about an inch above where it would normally be on the high mark. So what I'm waiting to see, I'll wait and see if there's, I don't know if there's an O-ring that seals this shaft or not, so I'm just going to see what actually oozes out of this shaft. Hopefully it's only a very tiny little bit comes out, not a flood and a gush. And we'll also see to make sure our wick's going to pick up the oil as well. So we'll let that sit overnight, and I'll come back tomorrow or the next day and have a look at it. The oil that I run in my machines and the headstocks and aprons and that, it's just 68 grade hydraulic fluid. So that's pretty good for a lot of lathes and milling machines. So I do tend to use a lighter hydraulic fluid on the ways. Something like a 32 is ideal, and 68 is normally good for headstocks. Okay, so our theory of raising the oil level and letting a little bit ooze past the shaft here seems to work. We have a little bit of oil in the bottom of this cavity, so that means a little bit is dripping through, so that'll give a constant, just a very minute drip feed onto the gear, this bronze gear which drives the worm for all the feeds. Now looking at this gear, she's starting to get a bit gnarly, this. Actually, what I've got it out, it would be a good time to make a drawing of it, so that maybe in the future I can get a cutter and make a new one. That way I'll have a spare. The same with the worm. So that's no dramas. Okay, now our wick idea that we went through, we'll bring you in a closer look at that one. Okay, I'll try and hold the camera still. So that's our wick. So the idea was so it draws up some oil. You can see there when I press it, we have oil. So that's a good situation there. At least it keeps top of that slightly oiled, and a bit of it's going to levitate its way down into the slides, hopefully. So we had a win there. Okay, with the consequence of raising the oil level, we're getting a bit of leakage out of the opposite end of the shaft that our pinion sits on. So what I've decided to do, rather than put a seal in the housing or an O-ring on the shaft, because that will reduce the bearing area of the shaft where it goes through the cast iron housing, I've opted to make, well, a cover plate for it. So I'll get that made up. That way I don't have to strip. There's no reason for me to strip any of this out. All I've got to do is drill 2 holes and drill the other hole in for the oil level plug for the new oil level.